right? So the transition from a document-centric system engineering to model-based system engineering is ongoing. And actually, ESA have been promoting model-based system engineering for many years now. So more recent activities such as MB4SE seek to increase the adoptions of model-based system engineering within the space community. So within the MB4SE activity, some of the user needs have been defined by ESA. So managing the increasing complexity of space missions, supporting the compliance with best practices, ensuring the consistency, completeness, and feasibility of requirements and design, and ensuring stakeholders and non-MBSE proficient users, in understanding system design. So today, while there are still existing tools that, let's say, go in some way to achieving these needs, it's clear that these needs have not been achieved fully yet. So here, so this is we have collected the user challenge, all right. So most of the challenge that let's say the stakeholders, the users, but also let's say the people from the community face when adopting a model-based system engineering to their project. So managing model complexity. So as you know, spacecraft is very complex. So the system model is complex, right? But also the interoperability between different subsystems, right? Because in fact, different method, tools, but also best practice have been used to develop the different subsystems. Verification and validation. So model-based system engineering require extensive testing, but also validation to ensure that the model accurately reflects, let's say, the spacecraft system. And as you know, in space environment, testing opportunity are limited and very expensive. So that's also challenging. Then there is engineering culture shift. So again, model-based system engineering require actually a shift from, let's say, document-centric system engineering to model-based system engineering. All right, and that's also a challenge, especially for the users who actually get used to a traditional approach. And then you have the model management. So the model management, the spacecraft take a long time to develop. So, and of course, during that time, the model can become outdated or inaccurate. So the engineers actually have to make sure that to use the model carefully and to make sure that the model remain accurate and up to date during the design process. So today we have a new way of working in model-based system engineering. All right, so with its benefit and its limitation. So we have a new generation of AI assistants, right, that can actually assist in complex tasks, in completing, let's say, in complex tasks and also technical tasks. So yeah, and so now let's explore some of the use case that comes from marrying the two. So Ted, we're gonna hand you over to you.
Thank you, Yannick. Okay, so we've presented that essentially we're transitioning from a document-based way of working to a model-based way of working, and we've identified that there are some existing needs that are kind of being met, but not fully being met. And we have this new suite of AI assistants, new technology that's available to us. So let's kind of present a vision of how we use these AI assistants, this new technology, to improve the way we're doing model-based systems engineering. So the first kind of, I suppose, use case that we're going to propose here is aiding in the requirements compliance activities of a model-based systems engineer. So I have an example requirement up here. So in a standard space project, you might have hundreds or thousands. This is just one. So the example is a hazard detection and avoidance. So it's a rover, and we're saying that the rover should have hazard detection and avoidance capability. But I'm a model-based systems engineer. I'm trying to comply with thousands of requirements. I've missed this one. Okay. I want to check that my model is compliant with this requirement. So let's ask our AI assistant, am I compliant to this requirement? And in this case, no, I haven't. I haven't modeled it correctly. it's not compliant. I'm not showing how I'm compliant in any way. Okay, so how can I be compliant with this requirement? So we can ask our AI assistant this, and the assistant will say that we're missing some sort of functionality to perform a hazard and collision avoidance maneuver. And that's correct, I haven't modeled that. And this helps me then to identify that I've missed this element, missed the compliance with this requirement. And so in my system analysis diagram, I can then go and add an element in that system model that identifies, or that allows me the functionality, the system functionality, to perform hazard avoidance collision with risk. It's a simple example. When you're dealing with hundreds and thousands of requirements, these sorts of things do get missed. Second one, so another, I suppose, application for large language models here is reducing modeling error. So if there's any space systems engineers in here, tell me what's missing, what have I not modeled in this diagram? So the diagram is a mode state machine, so we're modeling system modes and transitions. So we have a pre-launch mode, launch mode, separation mode. Anyone spot what I haven't modeled?
Landing or recovery?
Well, I've kind of not included that part of the diagram because it'd be too big, but essentially what I've missed here is any way of getting out of safe mode, right? So you see there, I would have gotten into safe mode for whatever reason, but I would have had no way of getting out of safe mode. So in this diagram, I hadn't modeled a telecommand from my spacecraft operations center to move me from safe mode into nominal mode. That's, I suppose, something even on a simple diagram, as humans, we miss very easily. Imagine a system where you have, tens or hundreds of modes and however many more transitions between those modes. So these things, as humans, we struggle to identify. It's a very laborious verification process. So let's use large language models to help us with that. The third one, getting away from kind of a technical side of thing and more looking at stakeholders. So we identified earlier on the challenge with engineering culture shift, but that also applies to the stakeholders, right? So the people looking at these diagrams aren't necessarily skilled in model-based systems engineering. As we're transitioning towards document-centric to model-based, even the engineers aren't necessarily skilled in model-based systems engineering. So we need to make sure our stakeholders actually understand what we're modeling, what are the diagrams. So this is an example of a somewhat complex logical architecture of a spacecraft. And you can see there's lots of elements there, and there's lots of links between elements in that. So let's use a large language model to help us, or help the stakeholder understand and comprehend what the diagram is showing. So in this case, we're asking something from the trade study. So why did we choose loop heat pipes over other heat pipes? So we can interrogate in that sense. Or we can interrogate in terms of how does the thermal control system interface with the spacecraft bus. So there's elements, in a big complex diagram that would be, say, intimidating to a stakeholder who isn't necessarily educated or familiar with model-based systems engineering. Having a digital assistant to help us, or help the stakeholder understand what is actually being modeled is of real value. So yeah, that is as 3 use cases. So I'm going to hand back over to Sarah here, who's kind of round off our topic.
Yeah, so our hope is that we make everything more explainable via large language models. However, large language models are not knowledge data, or knowledge banks. So we have certain limitations when we have to concern about quality control and security thereby. So usually in large language models, we have a lack of domain-specific knowledge and data. Therefore, very specialized pieces of information are not contained, and we need to teach the system that specialized knowledge first. Also, it's a black box approach, and when it comes to quality, critical to quality assurance, we can't totally rely on a black box approach. So we have to take that black box part into our own hands and include a certain kind of interactivity via a human human-in-the-loop approach so that we can tackle these insecurities inside the system that is not provided by large language models. So the aim is to build an assistance system, not a replacement for the engineer that is doing the task. Yeah, that's it from our side. We're open to questions. Thank you for your attention.
So any question for the team? Also online? Okay, Luis?
Maybe one question regarding the first use case, the compliance use case. So if I understand